Hello and welcome back to the channel. In this video, we're going to be learning about the binary search in Java. Now, we learned that searching is basically when you check if a certain element exists in an array. Previously, we did that using the linear search. Now, a linear search is useful, but when you have an array with a large number of elements, it's very slow. So there you could use something like a binary search. And as you will see later, a binary search is way faster. So in this case, let's just take this array as an example. It has 5 elements, 5, 3, 10, 1 and 6. Before we run the binary search, there is one important step you need to make sure you do. We need to sort this array in a proper order. So we need to sort this array in an ascending order. And to do this, we could use something like a selection sort or a bubble sort. Once we sort this array, we're going to find out what's the middle element of the array. So in this case, the middle element is 5. And then we're going to check if the value that I'm searching for is equal to this middle element. Because if it is, well, we can just stop the program. We don't have to execute the program anymore because we found the value that I'm searching for. Now, an important characteristic of this array is that all the elements to the right of this middle element are greater than 5. And all the elements to the left of 5 are lesser than 5. And you can understand why this is because we've sorted the array in an ascending order. So if we're searching for something like 1, we know that the value is going to be to the left of 5 because 1 is lesser than 5. And if you're searching for something like 6, since the value that I'm searching for is greater than 5, we know it's going to be to the right of 5. And using this simple idea, we're going to write our binary search program. So let's just take this same array. You can see that 5 is the middle element of the array and 2 is the index of this middle element. Before we start any execution, we obviously need to find out what's the middle element. And to do this, we're going to define a lower and upper limit for this array. So if you take a look at this array, our lower limit is going to be 0 and our upper limit is going to be 4 because 4 is the index of the last element and 0 is the index of the first element. You can see that once I have a lower and upper limit, we can easily find out what's the middle element. The index of the middle element is just equal to our lower index plus upper index by 2. So it's just going to be 0 plus 4 by 2, which is 2. And you can see that using this, we can find out the index of the middle element of our array. But what if your array has an even number of elements? If you take a look at this array, you notice that it has only 4 elements. It does not have a middle element. But you can still take a lower index and upper index. And if we do the same thing, if we add the lower index with the upper index and divide it by 2. So in this case, basically when you add 0 with 3 and divide it by 2, you notice that you should get 1.5. But remember, whenever you divide an integer by an integer, Java will print an integer. So instead of getting 1.5, you only get 1. We ignore the 0.5. So the index of the middle element is actually just 1. Now it is true that it does not have a middle element, but for our binary search, we can assume that 5 is the middle element of this array. So in our original array, we notice that we find that 2 is the middle index of this array. What we're going to do first is, as usual, we're going to check if the target value is equal to the middle element of this array. If this is true, we don't have to execute this program anymore. We found our middle element. But if this is false, we're going to check if the target value is greater than a of middle. Remember, since our array is sorted, if our target value is greater than a of middle, it must be somewhere to the right of the middle element. So we'll just ignore all the elements to the left of 5. So now we're going to focus on the part of the array to the right of 5. So what we'll do is we'll change the lower and the upper limits. Remember, in a binary search, you search for all elements between the lower limit and upper limit. So basically, we're just going to say that our lower limit is going to be the middle index plus 1. And this makes sense. Since we're ignoring all elements before the middle index, we're going to change our lower limit to the index right after the middle index. So our lower limit is going to become 3. Now we're going to repeat the same process. We're going to find out what is the middle index for this part of the array. So the middle index is just going to be the lower plus upper by 2. 3 plus 4 by 2. Now 3 plus 4 by 2 is actually 3.5. But since we're doing integer division, we'll only get 3. So for this part of the array, the middle index is going to be 3. So 6 will be the middle element. We're again going to repeat the same process. We're going to check if the target value that I'm searching for is equal to 6. If this is true, we can just stop execution because we found the value that I'm searching for. But if it's false, we're again going to check if the target value is greater than this middle element. It's the same process. Now, if my target value is greater than the middle element, we can again ignore all elements to the left of 6. So now, we're only going to look at the elements after 6. In this case, since our target value is greater than our middle, we're again going to change our lower limit to our middle plus 1. We see that our lower limit is the same as the upper limit. Since we took a smaller array, this process is a lot faster. But if you took a larger array, you would have to repeat this multiple times to completely search the array. So over here, our lower limit is going to become 4. And we're again going to repeat the same process. So we're just going to find out what is the middle index of this array. The lower plus upper by 2 is going to be 4. So 4 is the index of the middle element. Now we'll assume that 10 is the middle element of this array. And again, we're going to check if the target value that I'm searching for is equal to this middle element. If it is, we found our value. But if it isn't, we don't have to search anymore because we basically searched our entire array. So we can stop any further execution. Now we'll get back to our original array. Till now, we've only checked if our target value is greater than a or middle. But what if our target value is lesser than the middle element? Remember, if your target value is lesser than the middle element, it must lie to the left of the middle element. So over here, we can ignore all the values after 5. And we're only going to concentrate on this part of the array to the left of 5. In this case, since we only care about the left part of the array, we're not going to change the lower limit, but we're going to change the upper limit. So we're just going to say upper is equal to middle minus 1. So our upper limit will be set to the index before this middle index. And this makes sense. We've shifted our focus on this part of the array just before the middle index. We're again going to repeat the same process. We're going to find out what's the middle index of this array. So that's going to be the lower plus upper by 2. In this case, we get 0. So the middle index is going to be 0 and the middle element is going to be 1. We're going to check if the target value that we're searching for is equal to this middle element. If this is true, we found our value. But if it isn't, we're going to check if the target value is greater than this middle element. So in this case, if our target value is greater than our middle element, we know that the value should be to the right of this middle element. So we're going to repeat the same thing we did originally. We're going to shift our lower limit to the middle index plus 1. So our lower limit and upper limit are basically the same. So our middle index will also become 1. And now our middle element is going to be 3. And again, we're going to check if the target value is equal to this middle element. If it's true, we found the value that I'm searching for. If it isn't true, since we've already searched the entire array, it means that we haven't found the value. So we can just print that we haven't found the value. Now we'll take another example, but we'll take an array which has an even number of elements so that we can understand exactly how the binary search would work with an even number of elements. So over here in this array, clearly we have our lower limit set to the first index, so index 0, our upper limit to the last index to 3, and we're going to find out what is the middle index. That's just our lower plus upper by 2. This is going to be 1. So the middle element is going to be 5. We saw this before. Now, once we find out what's a middle element, we need to check if the target value that we're searching for is equal to this middle element. Again, if it's equal to this middle element, I can just break this program and I can just tell the user that we found the value that we're searching for. So I won't have to continue this process anymore. Now, if it isn't equal, we're going to check if our target value is greater than a of middle. If it is greater than a of middle, we know that we're going to shift the lower limit of this array. We're just going to say that our lower limit is going to be the middle index plus 1. Now we are only going to focus on the elements of the array to the right of 5, because if the target value is greater than 5, since the array is sorted, it should mean that the target value should be somewhere to the right of 5. So we're again going to repeat the same process. We're going to find out the middle index of the array. So that's going to be 2 plus 3 by 2. Remember, because of integer division, we're just going to ignore that 0.5. Instead of getting a decimal answer, we will take the index as an integer. Now we find that the middle index is going to be 2. So the element at the middle index is going to be 6. We're again going to repeat the same process. We're going to check if the target value is equal to this middle element. If it isn't, we're going to check if the target value is greater than the middle element. And we know that if the target value is greater than the middle element, it must be somewhere to the right of the middle element. So we're going to shift the lower limit again. Our lower is going to be the middle index plus 1. We're again going to calculate our middle index. So that's our lower plus upper by 2. Basically our 3 plus 3 by 2. So our middle index is also going to be 3. So here we end up at one element, 10. So we're again going to check if the target is equal to our middle element. If it is equal, we're just going to tell the user that we found the value. But if it isn't equal, since this is our last element, we'll just tell the user that we haven't found the value. Now in our original array, we also need to check if the target value that we're searching for is lesser than a of middle. If it is lesser than a of middle, we can just eliminate or ignore all the elements to the right of 5, because we know that since this array is sorted, my target value must be to the left of 5. Accordingly, we're going to change the upper limit of our array. So our upper limit is going to become the middle index minus 1. So once we find the upper limit of the array, we're going to have to calculate the index of the middle element. This is just 0 plus 0 by 2, so the index of the middle element is also going to be 0. 3 is going to be my middle element. Once we find the middle element, we're obviously going to check if the target value is equal to this middle element. In this case, since 3 is the last element, if my target value is not equal to 3, that means we haven't found the value in the array. So we can just tell the user that that particular element or value does not exist in this array. So a question you might have is, how exactly do we know when we stop searching for a value in our array? For example, in this array, I've searched the first 3 elements and I've come to the end of the array. I've narrowed my search down to just one element. As usual, we're going to check if the target value is equal to this middle element, which is 10. If it isn't, since we've eliminated all values less than 10, our target value must be greater than this middle element. We know that when our target value is greater than a middle element, we're going to change the lower limit of the array. So our lower limit is going to be the middle index plus 1. Our lower is going to be 3 plus 1, basically 4. Now we notice that our lower limit is actually greater than our upper limit. And it is counterintuitive because we know that our lower limit should always be lesser than our upper limit. We notice that whenever our lower limit goes higher than our upper limit, it means that the target value is not in the array. This only happens once we completed searching all our elements. To make sure this works in all cases, let's assume that instead of arriving at 10, I narrow my search to just 3, the first element. Now in this case, let's say that my target value is lesser than a of middle. It's lesser than 3. As usual, we're going to change the upper limit. Our upper limit is going to be the middle minus 1. Since our upper is 0, it's basically going to become negative 1. Again, we notice that my lower limit is greater than my upper limit, and therefore we can say that the target value is not inside the array. And it makes sense. Our lower limit only becomes higher than my upper limit once we complete searching all elements of our array. And this is what we use to stop searching for a value. Now we look at a program that can use the binary search to search for a value in an array. So I wrote down 7 steps over here, and using these 7 steps, we're going to write a program to implement a binary search and check if a value exists in an array. So if you look at the first step, It's basically to ask the user to enter a value to search for the value in an array. So over here, I already made an array called A, which has 5 elements. Using the scanner class, I'm asking the user to enter a value, and whatever value that the user enters, I'm storing it in this variable called target. Our next step is to initialize two variables, lower and upper, for the lower limit and the upper limit of the array. This is pretty simple. So we'll just make int lower and we'll set it to 0 because 0 is the index of the first element of the array. We're going to make our int upper and we'll set this to 4 because remember our array has 5 elements and the index of the last element is going to be 4. Our next step is to find out the middle element of the array. So we'll just make a variable called middle, int middle, and this is just going to be our upper plus lower divided by 2. After we do this, we need to check if the target value is equal to the middle element. If it is equal, we need to print that we found our value and we need to break the loop. Now, we're not going to make our loop just yet, but we will check if our target value is equal to the middle element. So over here, let's just use an if statement and we'll just check if the target value is equal to a of middle. If this is true, we found a value, so we're just going to print that the value was found in the array. Eventually, we will need to add a loop, so we're just going to add a break statement over here. We also need to check if the target value is greater than the middle element. If this is true, we need to change the lower limit of the array. We're going to use another if statement for this, so we'll just say if my target value is greater than the middle element of the array, we're going to change the lower limit to the index of the middle element plus 1. We also need to check if the target value is lesser than the middle element. If this is true, we need to change the upper limit. So we'll add another if statement over here, which basically checks if my target value is lesser than the middle element. If this is true, it's just going to change the upper limit to middle minus 1. And then our last step is to repeat this whole process. Now, usually you would use something like a for loop, but in this case, a while loop is much better because we don't really know the real number of times we would have to execute my for loop to find out if a value exists in an array. Instead, we would use a while loop. Now, previously, we learned that once we search all the elements of the array, our lower limit is actually going to go greater than my upper limit. So a condition should make sure that this whole piece of code executes as long as my lower limit is less than my upper limit. So our while loop is going to look something like this. While my lower limit is lesser than or equal to my upper limit, which is going to execute this piece of code. So let me just copy this and paste it over here. Now we notice that I'm telling the user if a value is found, if I found that value, but I'm not telling the user anything if I didn't find that value. So what I need to do is I need to add something like an if statement or a println statement basically to tell the user if the value wasn't found. Now we know that if my lower limit is greater than my upper limit, it means that we haven't found a value. So we'll just add this if statement over here. If my lower limit is greater than my upper limit, it means that we haven't found our value. So we're just going to print that our value wasn't found. And now we'll just run our program. So when I run my program, it asks me to enter a value. I'm going to enter the value 7. As we can see, the value 7 clearly exists in the array. And when I click enter, it does tell me that the value was found. Let's run this program one more time. And now let's enter something like 30. Now the value 30 does not exist in the array. So it should print that the value wasn't found. And when I click enter, it does print that the value wasn't found in the array. So it works perfectly well. And that's it. That's all you need to know about the binary search in Java. I hope you liked this video. Thank you for watching and have a great day.